All right, we looked at simplifying radicals, and today we're going to look at solving radical equations. So what makes something a radical equation? Well, the word equation means that it has an equal sign. And when you see an equal sign, that means you can solve for your variable. And then to make it a radical equation, it has to have a variable under the radical sign. And like I said, when you have an equal sign, you can solve for your variable. So what are the steps for solving a radical equation? The first thing you want to do is isolate the radical term. So that means get that radical by itself. And then to get rid of the radical sign, you raise each side to a power equal to your index. So if you have a square root, square both sides. If you have a cubed root, cube both sides. Once you've done that, you get rid of the radical sign and you can now solve for your variable. Now, when you have a square root or a radical, it's always good to, you need to check your solutions to make sure that they make the equation true, especially when you're dealing with a negative, and I'll show you one example later on. So always make sure to check your solutions when solving. Okay, so let's practice. Square root of m plus 4 equals 7. To solve, first thing I want to do is isolate the radical. So I'm going to subtract the 4 from both sides of the equal sign, and we get the square root of m equals 3. Now that the radical is by itself, I can get rid of the square root by squaring both sides. Remember, whatever you do to one side, you have to do the other side. The square root and the squared cancel, and I get m equals 9. And then I'm just going to make sure to check my solution in the original equation. So I'm going to plug in 9 for m, and I'm trying to see if the square root of 9 plus 4 equals equals 7. That's what I'm checking. This is 3 plus 4, and that does equals 7, so this checks. So this is a solution that works. Okay, for b, the radical is already isolated. There's nothing added, subtracted, multiplied, or divided outside of the radical sign. So I'm going to go ahead and square both sides right away. The square root and the squared cancel, and I get x plus 2 equals 9. Subtract 2 from both sides, and I get x equals 7. So to check, I'm going to plug in 7 for x, and the square root of 7 plus 2 should equal 3. And that is the square root of 9, which is 3, so that checks. So that 7 is a solution. Okay, in C, instead of a square root, we have a cubed root. So my index is 3. So to get rid of that cubed root, I'm going to cube both sides. So remember, the 3 goes into 3 once. They basically cancel each other out. And I'm left with 2x plus 4 equals 2 cubed is 8. Let's subtract 4 from both sides. We get 2x equals 4. Divide both sides by 2 to get x by itself. And I get x equals 2. I'm going to go ahead and check. It's also a good way just to make sure you solved correctly. So cubed root of 2 times 2 plus 4, this should equal 2. This is 4 plus 4, which is 8. So I have the cubed root of 8, which is 2. So this checks. This is my solution. Okay, for D, I have 2 radicals on one side of the equal sign. And don't write this, but if you went to go ahead and try and square both sides right now, like this, you would actually have to FOIL this left-hand side because of the subtraction sign. This would be the square root of 4n plus 5 minus square root of 7n minus 4 times itself, and then you would need to FOIL. And that is sometimes a possibility. You don't have a choice around that, but in this class, we're not really going to solve any like that. So the easiest thing to do right here is to move this negative square root over to the other side, so they're each on one side of the equal sign. And then I don't have to FOIL. So I'm going to get the square root of 4n plus 5 equals the square root of 7n minus 4. Now I can square both sides. The square roots are going to go away, and I get 4n plus 5 equals 7n minus 4. Let's go ahead and solve. So I'm going to subtract 4n from both sides of the equal sign, and I'm going to add 4 to both sides of the equal sign. And when I do that, I get 9 equals 3n. Divide by 3, and you get n equals 3. So I'm going to check. I'm going to plug in 3 for n. And I'm going to see if this works. It should equal 0. And when you just, 12 plus 5 is 17. 21 minus 4 is 17. The square root of 17 minus the square root of 17 is 0. So this checks. So this is our solution. Okay, so let me show you an example where, a really easy example where something might not check. Let's say I had the square root of x plus 1 equals negative 3. I'll come back and show you right away that this isn't going to work. Let's just say I went ahead and did all the steps, so I squared both sides. Square root and squared cancel. I have x plus 1 equals negative 3 squared is 9. Subtract 1 from both sides and you get x equals 8. Now if you go to check, you get 8 plus 1, and you're trying to see, does that equal negative 3? And this is the square root of 9, which is 3, and 3 does not equal negative 3. So it doesn't check, and so 8 is not your solution. You actually have no solution for this radical equation. And the reason being, when you look at the original radical, it's saying what square root of what number equals negative 3? And that's never possible. Square root cannot equal negative 3 unless you had a negative outside of the radical sign, which we don't have. So this has no solution, and that's why it doesn't check. Okay, let's do this example. The relationship between the flow rate R in gallons per minute of antifreeze for de-icing a plane, the nozzle diameter, and the nozzle pressure is given by this equation. You want a flow rate of 250 gallons per minute, that's your R. You want to find the nozzle pressure, or P, when your diameter, or D, is 1.25. So let's plug in the R of 250 into our equation and the 1.25 for our D and solve for P. So the first thing I would do is multiply 30 times 1.25 squared on your calculator, and you should get 46.875. And I would not round to like one decimal place until the very end of your solution, or to whatever you're asked to round to. But don't simplify till the very end. Okay, I want to get P by itself, so this is multiplication, so I'm going to divide both sides by 46.875. And when you do that, you get the square root of P equals 5.3 repeating. So I'll just write it like this. And now I'm going to square both sides to get rid of that square root. And you should get P equals 28.4 when I round. And this is P, pressure, and that says it's pounds per square inch. So don't forget your units. So pounds per square inch. Okay, example 2, one estimate for how far we can see on a clear day is given by this equation, where V is the visibility in miles and A is the altitude in feet. A woman on a hang glider can see 49 miles. So this is your V, and one way to tell too is that the units are both miles. You should always double check that you could have different units, but a woman on a hang glider can see 49 miles. That's her visibility. How far above the ground is she? I want to find altitude. So I'm going to plug in 49 and solve for A. So we need to divide both sides by 1.225. And you get the square root of A equals 40. Square both sides. and you get A equals 1,600, and then the units for A is feet. So she is 1,600 feet above the ground. And the last example, the distance d to the horizon for an object h miles above the Earth's surface is given by this equation. How many miles, so I want to find h, above the Earth's surface is a satellite if the distance to the horizon is 900 miles. So I have d and I want to find h. And you're going to have something similar to this on your homework. So this one's going to have some fun factoring in a minute. But let's plug in 900. Okay, so 900 equals square root of 8,000h plus h squared. I'm going to square both sides to get rid of the square root. I'm going to write the 8,000h plus h squared first. It doesn't really matter. I'm just going to put it first. Equals 900 squared gives you 810,000. Okay, this is a quadratic. I have a h squared h, and so I want to set this equal to 0. So I'm going to move the 810,000 over the other side, make it negative, and I'm going to write it in descending order. So I'm going to write the h squared, then the 8,000 h, then the negative 810,000. Okay, this is factorable, so I'm going to factor it. And it's large numbers, but the numbers are pretty close together. And so you just have to try different combinations until you see something that multiplies to be negative 810,000 and adds to be a positive 8,000. So one thing I know, since it multiplies to be negative, my signs have to be opposite. That's the only way you can multiply to be a negative number. And then I just have to figure out a combination that works. And I actually, with a lot of practice and trying numbers, see that 8,100, a positive 8,100, and a negative 100 is what works. Oops, that's 100 there. Because when you multiply these together, you get negative 810,000, and when you add them together, you get 8,000. So now that I've factored, I can solve. So remember, that means you need to set each one of your factors equal to 0 and solve for h. Fix this 0. Okay, here I'm going to add 100. So I get h is 100. Over here I'm going to subtract 8,100 and I get negative 8,100. This is a word problem, and so we can't say we're at negative 8,100 miles from Earth. It doesn't make sense. So this is not a solution to this problem. So the answer is 100 miles.